हेलो स्टूडेंट, आज की क्लास में हम लोग पढ़ने वाले हैं क्लास 12 केमिकल काइनेटिक्स चैप्टर। सबसे पहले हम लोग देखेंगे कि व्हाट इज़ द मीनिंग ऑफ केमिकल काइनेटिक्स। तो केमिकल काइनेटिक्स इज़ द ब्रांच ऑफ केमिस्ट्री in which we study about the rate of chemical reaction, and on the basis of rate of chemical reaction, the chemical reactions are classified into three different parts, which are slow reaction, fast reaction, and moderate reaction. The slow reaction which occurs very slowly, for example rusting of iron. Fast reaction which occurs very readily, for example burning of magnesium ribbon. And the moderate reaction which are neither too slow nor too fast. And on the basis of the above facts, we can understand that the chemical reaction are of three different types on the basis of their rate: slow, fast, and moderate. Now move on to the next topic, that is rate of reaction. What is rate of reaction? The definition is very simple. Rate of reaction simply means decrease in the concentration of the reactant and increase in the concentration of the product with the change of time. Here I have taken an example: A transformed into B. A considered as reactant molecule and B considered as product molecule. So the rate will be minus del A by del T equal to plus del B by del T. Such type of rate is find out in case of large difference of time as well as in the concentration value. So it is known as average rate of reaction. This is considered as average rate of reaction. And if we want to find out the instantaneous rate, now what is instantaneous rate? If we want to find out the rate in terms of concentration and with respect to small change in time, that is called instantaneous rate. So we have understood that what is the meaning of rate of reaction. Negative sign indicates the decrease in the concentration of the reactant. Here you can see this, that there is a negative sign which indicate decrease in the concentration of the reactant, and in product side there is a positive sign which increase in the concentration of product with respect to small change in time t. So what is the average rate of reaction? When we want to find out the rate of reaction with respect to concentration for a large difference of time, then it is called average rate. And for a small change in time, if we want to find out the rate of the reaction in terms of the concentration, that is called instantaneous rate. Now here you can see another example that we have taken: AABB equal to CC plus DD. So this part is considered as reactant and this part considered as product. So in the left hand side we can see there are coefficient A and B, and in the right hand side the coefficients are C and D. When we have to write the rate of the reaction for a such type of reaction, simply write rate equal to, for a reactant negative sign is used, coefficient is always written in the by 1 by A, del A by del T equal to minus 1 by B, del V by del T equal to, in the product side, that is plus coefficient written as 1 by C, del C by del T equal to plus 1 by D, del D by del T. So in the above example, we can see this, The negative sign indicates decrease in the concentration and positive sign indicate increase in the concentration. And the coefficient is always written in by. In other words, we can write rate of reaction equal to disappearance. Rate of reaction equal to disappearance in the concentration of reactant with respect to time t equal to appearance in the concentration of product with respect to time. So it is very simply we can write. Now this can be more clarified by taking some more examples. So let's see what are those examples that we want to choose. First example is N2 plus 3H2 reversible sign 2NH3. N2 plus 3 molecule of hydrogen reversible sign 2 molecule of ammonia. This is the reaction, and for this reaction we will have to write the rate of reaction. So very simply we can write this, and this is rate of reaction, reactant side minus del, concentration is written in the square bracket form by del T. There is a coefficient 3, so this can be written as 1 by 3 del H2 by del T, and this is in the ammonia is in the right hand side with coefficient 2 can be written as 1 by 2, and it is del NH3 by del T. So this is the very simple method by which we can write the rate of the reaction. Let us consider another example to find out the rate of reaction. So the example is H2 plus I2 reversible to HI. For this reaction you have to write the rate of the reaction. So this can be again very easily can be expressed rate of the reaction equal to reactant side negative minus del H2 by del T minus del I2 by del T. In the product side there is a coefficient 2, so it can be written as 1 by 2 del HI by del T. So by using the rate law, we can find out the rate of reaction for any type of the chemical reaction. Now, there is a very important note that you must remember. Note that rate of a chemical reaction, rate of a chemical reaction, any chemical reaction's rate is directly proportional to the concentration of the reactant to the power n. N simply means order of the reaction. So today we have completed the basic introduction of chemical kinetics and the classification of the chemical reaction on the basis of their rate, writing rate law, and explanation of rate law by taking some suitable examples. In our next class, we will discuss about another very important topic from chemical kinetics, and that is the factors affecting the rate of the chemical reaction. The different factors which affect the rate of chemical reaction, that will be discussed in our next class. And if you like this particular class, then do consider subscribe, and whatever be the doubts you have in your mind, you can put that in my comment box so that I can help you to solve your problem. At this time, you are with Arunav's chemistry classes and myself, Arunav Chatterjee. Once again, I would like to thank all of you to join and watching this particular video class. Thank you.